Hey everybody, what's going on? Hope that woke you up. Yes, I'm going to be loud. Okay. As you can see here, we have two PCs, P0, PC0, PC1. These are two separate networks, 192.168.1.0.24 and 192.168.1.0.26. Obviously, if you're in the zero network here, I'm going to work this out for you. Okay. Let me see if there's notepad. Yeah, perfect. Oh, sorry. So let me put that in there for you. 192.168. Can you see that okay? You probably could. I'm the one that can't see. 0/24. What does that mean? What does that mean? X, let's put it in caps. X.x.x dot line 1, 2, 3, 4, 5, 6, 7, 8. Which means that the net ID that's what I gave you, 192.168.1.0, okay? And then the broadcast for that, I'm just gonna put broad, I don't feel like writing the whole thing out, 192.168.1, well, if you just add all these bit values up right here, it's 255, right? That will be your broadcast, 255, right? 255 plus 0 is 255. So the usable, usable, like that? Is that spelled correctly? I'm just gonna put the range, not show my spelling. Dot 1 through dot 254. Okay, let's bring this back, make it nice and pretty. All right, cool. So this can have an IP address. Why is that there? This can have an IP address of 1.1 through 1.254, and it can have whatever gateway. All right, cool. That's this particular network. There is no VLANs, no nothing. This would be considered a router and a stick if you're doing VLANs, right? All right, but we're not. We're not doing that. So the next one is 192.168.1.0 also, but with a 26. Okay. What does that mean? X.x.x dot 12, that's 26 bits, line 1, 2, 3, 4, 5, 6, right? To make a total of 8 bits. So your network ID, because we're using the zero network, 192.168.1.0. And I want to know what networking person is doing this, that this has to be something explained at the ENARSI level, the CCNP Advanced Routing and Switching level. Okay? Who's doing this? Broad. And now it's going to be the same friggin' broadcast, right? Because you have 2 bits on here. This is 64. So you add these, one less, 63. 63 plus 0 is 63. Cool, right? And then we're going to go dot 1 through dot what? 62. So can these computers talk to each other? Can these computers talk to each other? They're on different networks. So let's see. Let me come over here. Why do I have this? I'm in real time. Why is this envelope here? Okay, whatever. That went away. All right, so let's see the IP addresses that I've assigned to this PC. So this PC, well, let's do it the IT way, the real world way. IP config. All right, so we have dot, here's a dot 1. I don't follow those rules. That dot 1 is my gateway. Here's the 24-bit mask, and here's the gateway. I feel like putting that number. I can put whatever number I want, right? That's my gateway. All right, cool. And then this guy, 26, desktop, IP config, has 1.2, just to make it different, okay? And then we have a 192 mask, but I use 62. Why did I use 62? Because 62 is the last available IP address in this range. And that's normally what I do. But I want to prove a point. Yes, these computers can talk to each other. Watch. Now some of you are saying, Laz, we know this, man. What are you doing? Okay. And I can get to my gateway. Lovely. Obviously, if you ping one way, you can ping the other. Ping 192.168.1.1. Okay. and 62. Okay, why am I showing you this? A lot of you probably already know this, okay, because the first 62 IP addresses fall within this range. So if I were to put 254 as the gateway up here, obviously this is not going to be able to ping that computer, that gateway. But will it ping this guy if I put it within this range? Of course. But it's not going to go outside. All right? And this is what they're trying to explain. So you're telling me that somebody out there, that this needs to be explained at the NARCI level, which is the CCNP designation, okay, that, hey, everybody, use the same subnet mask, okay, and then you can have different networks, or, you know, don't like bad IP addressing stuff. It's like if you to choose an IP address within the range, okay, and then use that to be able to get up. That was just ridiculous. Who does this? Who does this? Because even if I VLAN this out, okay, then obviously what would happen? Come on now. If I were to put VLAN, let's say not 1, but let's put VLAN 10, VLAN 20, right? This would need to be a trunk port up here, and then I will have to do under the sub interfaces, right? Let's do it. All right, so enable, conf T, VLAN 10, name, obviously my favorite department, HR, okay, and then VLAN 20, name, that's another thing, my favorite department, payroll, get paid. All right, let's do a show VLAN brief, make sure they're there. Lovely. Now let's assign them. All right, config T, int F0/1, switch port mode access, switch port access VLAN. This will be VLAN 10. Cool. Then we go to int F02, switch port mode access, and then switch port access VLAN 20. Lovely. All right, show VLAN brief, and there they are. So now that's there and that's there. So in order for this to work, let me fast forward through time. That's what I love about the packetization. This has to be a trunk port, because VLANs that we create do not have the actual tag per the PVIN. All right, the port VLAN identifier. Ooh. That took back, I had to reach back in my brain. The port VLAN identifier, it's not on the VLANs we create. So that's why they must go through a trunk port, because it's multiple VLANs. But more importantly, it's got to get tagged. Okay? Hey, you're VLAN 10. Hey, you're VLAN 20. So let's go back in here. We're going to go into int G0/1. Oops. Conf T. Int G0/1. Switch port mode trunk. It's a pure layer 2 switch, so you can do that. If it's a layer 3 switch, meaning if it's a let's look at the switches. If it's a 3560, it's 2 commands. If it's a 3650, it's the same command, just 1 command. Okay, so now that's that. See what happens. See what happens. Because it's on the physical interface, right? They both have the same gateway. But let's see. Let's see. Let's see. Let's fast forward through time. Again, that's why I love this. So you can't ping. Oh, okay. So now we need to go ahead and put actual gateways. So let's go ahead and put specific gateways. So in a 24-bit mask, I always use 254. All right, .254. I always use the last available IP address. Why? Because I can. All right. What rule says that I can't? And then this is already the last one. So you have 2 separate networks here, right? 2 separate networks. They're in their own VLANs, because we want to create more broadcast domains, less broadcast on the network, right? Security, efficiency, all that good stuff. Let's go to the router. Cool. Now we want to do what? Sub interfaces, yeah? Because we got to do the encapsulation. So we go to interface G0/0, Just turn it on, open the door, and you see the people. No, I'm just kidding. Interface dot 10 for VLAN 10. Encap .1Q10, and then the IP address 192.168.1.254.255.255.255.0, right? Excuse me, it squeezed me. I didn't get rid of the physical interface, probably interface G0/0. So you just put no, not MP, not military police, no shot, no IP address. Sorry. All right, let's go back into subinterface G010. Oh, that's encapsulation. Sorry. Really? There you go. Interface, encap, and then the IP address. Come on. Cool. Because I never removed the IP address from the physical interface. Now let's do the other subinterface, which is int G0/0.20 encap .1Q20 IP address 192.168.1.62 255.255.255.192. Excuse me? Why? Why? Let's take a look at this. Show IP in brief. This is 1.254. Okay? This is 1.62. Oh, it falls within that range of the. So since this has a smaller mask and it encompasses these first two IP addresses, apparently it has an issue unless I do this. 27, right? So now the range is different. I'm still going to use a zero network, but a zero network that increments by 32, correct? So 0 to 32, 1 less, 31, that's the broadcast, 30 is the gateway. So there we go. Will it still overlap? Let's find out. So let's go to config T, interface G0/0.20, encap .1Q20, IP address 192.168.1.30. Oh, sorry. 255.255.255.224. Still overlaps. So how far do I need to take it out? So that's the thing, you're using the zero network, using a 24-bit mask. So, ladies and gentlemen, okay, when you're configuring this and you're going to be using VLSM, or if you use different subnets, be careful. If you're using a 24, it will encompass anything else. Now, let's say that this is a 30. I'm using, no, 32, sorry. That's the network, sorry. Right, it's 032. Now that's a complete different network, but 0 is a network. Okay, so 32, 64, 1 less, 63, 1 less is 62. So this is a, I'm sorry. Let's go here. So this will be, now, this will be 27 to 24. Oh, that's what I put before. Sorry. Silly me. So I'm using a 32 network now. I'm using a 32 network, so it's 32, 64, 1 less 63, 62. So this would be 62. But now we're using that. So we can't use 2. We can't, see, it doesn't even take the gateway because we're not inside that network. 33. So now we can put 192.168.1.62, right? It allows us to do that because it's a completely different network. The IP addresses, even though 32, doesn't that fall within that? Okay. Is that going to work? Am I in a different network altogether? 27. Hello? What's going on? Okay. Let's put IP address. Well, no, I'm not going to do it that way. I just want to make sure Well, I am under end cap, so IP address. Let's maximize that so you can see it nice and neat. IP address 192.168.1. It was 62, yeah? Yeah, because the 32 network, 62. 255.255.255.224. Still overlaps. So, when you're doing this, okay, this is the first freaking lesson, okay? In there, it just makes no sense. So, what this is VLAN 10, VLAN 20, they're assigned to their own VLANs. I'm doing sub interfaces for this, okay? And since this is a smaller mask, that would be the issue. So how would this work then? Well, it would work easily if this would be 2. Well, let me just erase the whole thing. 192.168. Oops. What happened here? 192.168.2.0. 192.168.2.0/24. 2 last 2. My God, don't let your fingers do the walking. All right, so now using the same subnet mask, but we're in different networks. 1.0, even though we're in different networks before, but because that mask, because they're trying to give you some binary definition that's no. This is the reason why. All right, 1.0, 2.0, cool. 2 separate networks. The IP addresses will not fall in there. Okay, so this is using 1.1. Okay, I'm gonna come in here and say 2.1. Okay, and then 2.254. Awesome. Let's go inside the route. Let's make sure I got it right. Hold on, because I know me. 192 say 2.1. Ah, you see? I know me. 0. 24-bit mask, and we're using a 254. Lovely. Okay. And let's go to the router again. Let's maximize it so you can see it. So we're going to put IP. Oops. IP address 192.168.2.254. 255.255.255.0. No overlapping. Show IP in brief. Because now we have 2 separate networks and show protocols using the same subnet mask, right? So it's going to say, okay, this is one network. This is a different network, all right? They're not going to overlap with each other because in the range, if you have a smaller prefix, right, like we did earlier, if you have a smaller prefix like 24, these IP addresses, it encompasses all these IP addresses. You saw that I tried the 192 and I tried the 224. Not happening. It overlaps. It overlaps because those IP addresses are part of that. But you saw that I can ping each other. I may not be able to get outside, but I can ping each other. So I am hoping that this is not the case that people are doing out there. This is why I say that knowing how to IP address properly is crucial. And I guess that's the reason that in the NRC, they're trying to show you this in the most complex manner whatsoever when it's very simple. I've always said it. The subnet mask is king. That will tell you what your subnet is, what your network is, how many IP addresses fall in, the host addresses, how many are in there. So again, if you put a 24 and then you're using one more a little specific, which is a 192, okay, that it's going to encompass in whatever's in here. So you got to be very careful when you're doing this stuff, and that's why you get overlapping IP addresses. All right. So yeah, in your LAN, I know that we like to use VLSM, but VLSM, remember what VLSM was for. VLSM was used or was designed, created way back in the 90s because they knew for a fact that there weren't enough public IPv4 addresses. Okay, that's the reason. So don't be doing IPv4 in your friggin' LANs. Use 24s all the way across. Use a Class B, use 24s. You can create a ton of friggin' networks. All right, that's it. Or Class A, whatever rocks the boat, whatever makes you happy. Okay, but that's the reason why. I pray that there's nobody out there doing this kind of stuff, meaning 1.0, 1.0, different masks, and just using a different number within that range to be your gateway. Don't do that. Don't do that. Don't do that. Okay? You need to pay attention to what you're doing. I hope this brings a little bit of more light, all right, to the subject. But in IPv4, the subnet mask is what dictates everything. Okay? It dictates everything. So play around with this and take a look and do something like I did right here, where I can see the ranges. You can see it clear as freaking day. If you use the zero network, different mask, especially this being a 24, these fall in here. I'm being repetitive now, so I'll let you guys go. Do this lab so you can see it happening. If you already know, more power to you. You're the proper network engineers that learn how to do things. If you're running into this issue, hello, be very careful. And again, chapter 1, the NRC. Cool? See you in the next one.